Okay, I think we're all ready to go. Perfect. So I'm not sure if the mic's working, but bear with me. So first of all, thanks very much, guys, for coming along this evening. For some of you, maybe your first time at Juggle. For some of you, maybe not. So to introduce myself, for some of you, I don't think maybe know me yet. My name's Carl Penhale. I work for Austin Fraser, who kindly sponsor and help organise the event here. So I myself look after the Python and Django space at Austin Fraser. So a lot of you may not have spoken to me yet, but hopefully sort of in the future will do. To start off with, just a few thank yous really. So first of all to Austin Fraser, me, myself and John, who probably some of you know as well, do sort of help out with this event, providing sort of pizza, beers and things like that. So that's a big help. And also to the guys at sort of Potato for this evening. We do try and host a lot of the events around London, so it's always nice to have a venue like this. So thanks very much, Stephanie at the back, and Jason, others from the company as well. And also a big thanks to you guys and also the speakers. Obviously, part of the reason that we do this is to find out exactly what's new in the market and the space in which we all take an interest in. So for you guys, the plan is to do this now sort of every 3 months. So if you're interested in either having a chat about talking or maybe hosting one or anything like that, then feel free to sort of give me a shout afterwards. So we're going to go. We've got a few speakers this evening. First of all, we've got Vlad from Essence Digital. He's going to sort of do 10-15 minutes there, followed by some questions. Probably going to go for about half an hour, 40 minutes in the first instance, take a bit of a break, and then after that, come back for the last few. Pizza and beer out there as always, so feel free to help yourself. Okay, but first of all, we welcome Vlad.
My name is Vlad. I'm a recovering Django developer. So unfortunately, the talk is not going to be strictly about Django. I tried to tie it into Django, but then I noticed that I was struggling more software development than just Django. So I decided not to mention Django at all. I will mention. I will. Along all the years that I spent in software development, I was always worried about the problem of actually specifying stuff in the correct way so that you can build the things that match the expectations. And when I went through phases of doing many things, like specifying everything in Gherkin, keeping it in files, and putting it somewhere, and then specifying it in tests, and then other places, and it never actually clicked together. I never found the pattern to be able to explain to business what the software that I was developing for them actually did. But now it has changed. I think I found the pattern. I called it executable specification. This is obviously not my trademark. Probably all know the notion of executable specification when you basically write a description of your software in So there are different schools on how to test it. I personally subscribe to a school which says you should probably mock out all the dependencies and just test your logic because all the other stuff has been already tested. So I'm basing this is my basic assumption about how to test stuff. Now, some people think that this is too broad. So can I?
Yeah, of course. Thank you.
So some people think that this is too broad, that obviously testing the whole API is not a good idea. But most people always say that you should probably modularize your systems so that there's a number of APIs that communicate with each other, and you keep the size and coherence of your module behind the API to the sensible size. Right? So I'm going to assume that yes, we can actually deploy a black box with logic in it, and we can mock out the outside world. Right? So effectively, this is what I want to achieve. I want to surround my logic with fake file systems. I'm going to program to send the responses to logic that is not going. The logic shouldn't be able to understand that it's not an actual file system. I'm going to use probably ports and adapters to do it, or maybe some other tricks, mocks, whatever. Same thing is going to happen with the database. So that is the thing that is really difficult in Django work, because you guys, well, we are quite coupled to the database by ORM. It's difficult to actually set a boundary there, but there are ways to do it, and maybe it's acceptable to sometimes pay the price of communication with database. So again, there's a space for moving left or right and accepting that maybe you get to couple the database. But yeah, third-party REST APIs for coordinates. And then you want some kind of a fake API, and in your world is the request, the fake request that you send to the APIs that you use. So we have a logic surrounded by fakes. Now, the decision we have to make is, how do we drive our fake API? So what kind of calls do we make to the API? So very often at this point in time, we start writing calls that are based on specification that is quite fluffy, and we do not fully understand it. So I think that we have to change that. So the situation with many companies is that your specification is actually all over the place. All right? There is a little bit of specification in Jira tickets, and this is specification that you got for the current sprint. Unfortunately, the current sprint is finished at some point in time, you move on, and that specification is still left in that ticket. Yeah? So you have to then dig it out. There is some specification in the wiki. Unfortunately, wiki gets out of sync, and nobody actually self-reports it and changes the wiki. Email, yeah, of course, you will receive an email about changing specification from someone. Wireframes, well, they describe the front end, they don't really describe the functionality, for example. You will have code comments, which is brilliant. I do this because the customer has requested something. And the tests, which is actually probably the best thing, because tests actually execute the code that does the things. But then again, who makes sure that we understand why the tests are doing the things that they are doing? And there's a blah, 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 which is basically like a noise. We sometimes introduce functionality that wasn't really asked for, right? Because we think it's a good idea. Because the customers, after all, they don't know what they're doing. Actually, I heard that recently. Right, so what I'm saying is that we have to put order into it, right? And the way that I see that order is after reading a book by Goiko Ati. Book is called Impact Mapping. And that book suggests that you can think about business in a very simplified way by building a mind map. Okay? So in the center of that mind map, what I'm putting is the goal that I want to achieve. Right? And that's a goal, business goal. That's strictly not software related. So it's not deploying a new database or upgrading to Django 2.9 or whatever the newest version is. Right? The goal is business related, means that we do something for the business, we achieve some results, and then usually people either give us money or pat us on the back, or whatever that is that the business is about. And then once you identify the goal for the business, you can identify who are the actors. So who are the people that actually do things for the business in order to achieve the goal. And once you've achieved the goal, once you know who your actors are, you have to measure what are the actions that they take in order to achieve the goal. Right? So this is like a very simple framework to make sure that you do not repeat yourself, that you do not describe the same action in two different ways. Right? Because if you have two actions that are identical and you've got two different actors doing the same thing, maybe you have to change your thinking, because you really have to have only one actor doing the thing. So that helps a little bit putting an order into what it is that people do in order to achieve a goal for the business. Right? So this is the idea of the mind map, and I've changed that mind map into something a little bit more tangible, like a real thing. So it's not real, but hey. So the company that I'm postulating here is actually making the best CV database in the world, right? So we can have users. So I identified three actors. One is user, one is a corporate user who's interested in hiring people, and there is an admin who has to basically manage the things. So I've identified some of the actions that they take in order to achieve the goal of having the best CV online database ever. So the users have to manage their CVs, they have to update it somehow. The corporate users have to be able to scan through the CVs, and the admin has to be able to manage both kinds of users, right? Whether they are users or corporate users. This is extremely simplified, I'm just trying to show the pattern. Right? And then what I have to do is I have to basically describe how my software actually allows these people to do the actions that they do. So let's let's go into search users. So what do the corporate users do, right? Well, they have to be able to find a CV if there is a match. And I'm using Gherkin as a DSL here. It doesn't really matter whether it's Gherkin or not, but I like Gherkin because it's simple, and most people actually are quite familiar with it, and it sounds almost like English. So, given I'm a corporate user and there is a user, when I search for that user, I can see many results. Now, please notice how high level that is. Right? I'm not saying about there is an interface and I log in and there's a box and I click it and I type in or anything like that. I'm not interested in that stuff. At some point in time in the future, I will be interested in that stuff. But right now, I'm just trying to describe what is the functionality that I have to provide to the business. Right? The idea here is that the functionality for the business is not going to change drastically. Your implementations may change drastically. Someone may change the color of the button from red to green at some point in time. But functionally, the same thing happens, right? So I'm trying to build a little bit of an indirection there from my DSL to the implementation. I want to talk about ideas that people will understand. I don't want to talk to the, this is a means for communication with people who are stakeholders, who actually are not maybe technical people. So I don't want to tell them that I've got a database or that I've got a cluster or I've got something, HTML, CSS. They don't want to hear these things. They just want to hear very basic things, which is there is a corporate user and there is a user somewhere and they search and they find them, right? So that's, many people call that a scenario, right? So that's one of the things that we have to make sure that our software does that. So moving to another scenario, I'm describing what's happening if the corporate users, they search for something that actually doesn't match my user that I entered into the database, right? So I'm trying to build a bunch of scenarios around my software that actually describe like those boundaries, you know? So if my system fits in the middle of different boundaries that I'm going to create, there's a pretty good chance I'm delivering a system that functionally meets the needs of the company, right? It may not be extremely precise, it may not be 100%, but I find it extremely cost effective. And having that tool of communication with people is extremely important, right? So yeah, I'm not going to read through it because it's really nonsense and it's really not a real CV database, okay? But I have that file for every single action that people can do. So this is how I organize my Gherkin files. That was always a big problem for me to say, okay, I'm going to write a bit of Gherkin, but what do I put and where, right? And usually I ended up with like hundreds of those files in some strange places, and I didn't know I would duplicate the same functionality description, and just didn't make sense. So trying to keep that pattern of having a mind map where you have the goal in the middle, the actor around it, and the action actually increases your possibility that you will not duplicate your specification. Right? Doesn't remove it completely, but if it doesn't remove it completely, it shows your business that maybe they haven't identified the actors properly, or maybe they haven't identified the actions properly. Yeah. So it's a means of actually talking to the business. You know. Yeah. So I have this file for the user, for the corporate users, and I've got two completely different files for the admin because they do two completely different things. One is managing users, the other one is managing corporate users. Right. And in each of those files, I will describe a few boundary scenarios, right? Obviously, these are nonsense, but hey, it's not the idea is to show you this, right? So what I end up with is a mind map where in the center is a goal, around I've got actors, then I've got actions, and to each action, I'm attaching a description of what does my system do in order to support this action. Simple, that's all. So this is what I call executable specification. If I create this mind map, if I attach my little files containing Gherkin or whatever, I mean, if you're dealing with data, lots of numbers, probably you might want to go for HTML tables with numbers, you know, I don't know. It's really not important what language you use. What is important is that you organize it very carefully, right? So yeah, once I've got these files, well, then there is a very simple thing to do. Take these files and put them all in one place. Do not allow people to send those files around. Do not allow people to edit them. I mean, if they want to edit it, yeah, well, they won't, but they have to go through code review. So I stick them into an access repository, right? And in the company I'm with right now, we are trying out a pattern where access repository is actually owned by product people. So the developers, they can still contribute to that repository, but they have to go through a process of actually forking the repository, making changes, and then trying to do the pull request on a fork, right? And all this is about making sure that there is a bunch of people who actually totally control the quality and the content of the specification that we've got. because they use it to communicate with the rest of the business. They will go to a user and say, do you think we have to think about this scenario a little bit more? Do you see a boundary that we have to fulfill? Right? Well, anyway, so I've got the access repository, and I can follow all the patterns that you do with code, right? I can have versions, I have branches, I can have one stable branch in the middle that actually describes the functionality of my system as far as production is concerned. So there are many patterns that you can use there. What is very important is only one thing, is that every single specification, be it Gherkin, be it a wireframe, be it a HTML table, is in one place. People are not allowed to actually copy-paste it around in tickets, Jiras, wikis, nothing like that. Provide a link to a repository and talk about it. Don't copy it out. So we make sure that you've got a single source of truth. Right? So this is what runs my tests. Right? So I now know that my question mark that I had previously in order to talk to my fake API, there's no more question mark. The only thing I have to provide is a layer that translates the executable specification into the executable bit. So we use behave, because it's simple, right? And it's very lightweight. You might want to use something completely different. It doesn't matter at all. What matters is that you have shared view of what is the functionality of your system, and you provide a layer that executes that shared view on your code base. Right? That's all. There's nothing more. It's an extremely simple idea. So the only thing that it really does, it introduces the idea you need a mind map. You need to understand how your specification files relate to each other. And if you have this, you are in a much better place because you understand what your system is. And interestingly, that shows you that everything that happens after the test runner, behind the test runner, is not important. Because once you have a set of specification files that can be executed on an API, it doesn't matter anymore whether you write it in PHP, in Django, or in any other technology. What matters is that you are delivering software that does for the business exactly what it says. Right? So you are pushing that idea of there is a bug in my software from the software to the idea of planning, to the moment when you actually write the specification, when you do your diagrams, when you talk to people. And I think it's quite powerful. You know? So yeah, what do I get out of it? Executable specification gives you single source of truth, right? We always can point a finger, this is what we do, right? There's no two versions of the same file. There may be technically two versions, but we know why there are. Because we've got a production version, and we've got a change request, and they have to meet at some point in time, right? So this is exactly what we do via development, right? We've got a tool to communicate with stakeholders. Many stakeholders are afraid of looking at tests and looking at code, but when you show them something that looks more or less like English, it changes. I had an experience in Bank of America when I actually tried to introduce we actually did introduce that, and additionally what we did, we followed the domain-driven design. So interestingly, the files that we were creating were describing I wasn't supposed to mention microservices or hexagonal architecture, but they were describing modules that were matching one-to-one the business functionality that these people were familiar with. So they were totally happy to actually take part in creation of the specification because they knew what they were talking about. We were not talking about the business, sorry, about software. We were talking about business processes, describing them and suggesting that some of them may be automated. So yeah, that actually opens the possibility of actually having people. This is the golden dream of Agile, right? Let's get users to sit with us and talk to us. This is a tool for us, right? You can actually do this with this tool. And yeah, the artifacts. Yeah, so the same artifact drives everything that you do. Communication, tests, development, QA, anything that you do is driven by the same functionality. Right? You might end up with some other repositories, for example, for the front end. Why not? Yeah. But functionally, you still cover with one idea. This is what we provide for the business. This actually puts testing as a first-class citizen. Right? You cannot start doing any development before you have executable specification, because that's the only way that you are going to get your software described. And this is a good thing, because it puts on people the weight of actually, they have to start thinking about what the software is doing. Right? They have to start describing it. And that opens the possibility for the QAs to write automated tests as an API, and all that can happen in parallel with development. This is very good, okay? Because you have regression pack for free. Yeah? Every single time you test something that has a functionality, you store it forever, right? And you just rerun it. And yeah, as I mentioned earlier, that repository actually holds the value. Yeah? Software becomes secondary. Software becomes something that has to happen because somehow you have to make those tests fast, and then some other people will be happy with it. But really what is valuable for the business is that you understand what you have to do for the business. Right? And then you can, if you have scaling problems, well, you just have to change your implementation. And it really becomes just change your implementation, because functionally it's not going to change. Right? That's it. My name is Vlad. I work for a company called Liquid Ant Limited, currently with Essence. And if you have any questions, I'm happy to answer it. I can also answer questions about testing, hexagonal architecture, and microservices. Whenever I can.
Great stuff. So, guys, if you do have any questions, feel free to crack on. I'm going to get the slides set up for the next one. So, yeah.
Yes.
So I was wondering, when you're building a mind map, are you just doing it on a whiteboard or?
Yeah, well, we started doing that on a whiteboard, but very quickly it becomes too cluttered, you know. So there are two ways to go about it. I personally prefer to use it on an online tool called MindMaster. It's a tool where you can basically share maps and cooperate on them online. Some people prefer to split mind maps into sub-mind maps. So they would have like a one mother mind map, and then maybe that's describing the big process of the company. So they start with a brief, and then they've got a proposal, and then there is a sign-off. So each of those phases would be actually in details described in a sub-mind map. That again, that depends on your size, right? On the size of the functionality that you are trying to deliver. Yeah?
And then will you then convert that into smaller files?
I don't. I actually keep the mind map as it is. The only thing that I do is that those end nodes that describe the actions, I actually put direct links to the repository that holds the access in them. So when you have a look at the mind map and you browse through it, you should be able to click on the last node, and that takes you to the description of what's happening in order to fulfill that action. Yeah? So that ties in nicely. And additionally, I didn't mention it here because I didn't want to be too Gherkin specific. But if you hear about that stuff that we usually put on top of Gherkin files, as a I want, so that, this is your mind map. As an actor, I want to make an action so that the goal is fulfilled. So this actually ties in together the files, the scenarios, you know, the feature file with the position in the mind map. I thought that this is quite a thoughtful way of thinking about organizing this specification. Yes.
In your test repository, it's literally just the Gherkin. It's none of the actual code.
Yes. Yes. So repository ends up describing actually the capabilities that are needed by the business, not software. So what we do is that we then can have a number of tools that fulfill bits and pieces of that needed functionality, and each of them would execute their part of access. And how you handle with it? Well, we ended up handling it with it by tagging feature files with the name of the tool that is fulfilling that feature file. Right? So each tool would basically import the whole shebang, the whole specification, but ignore everything that is not tagged as this is yours, right? Which makes sure that whenever you change specification, each tool is going to break, providing access changes. And that is extremely important. We want that to happen. Or not that, yeah? Because it's going to pick up something like that.
Stuff. Guys, if there are any more, what I'll do is we'll get this moving a little bit longer.
Was I talking too long?
No,
you wanted something longer than 5 minutes, so I delivered.
But I'm sure if I know you well, you'll probably be around for a period of time afterwards.
I'm not.
Okay, so if there are any more, we'll do a couple per person, and after that, if there's anyone else with more questions afterwards, we can grab a beer then. Okay? So once again, thank you very much. Perfect. So guys, obviously as you can see up on the screen now, so we've got Gary here. I'll hand you straight over.
Okay, here. I'm Gary, I work for a company called Chromium. I'm not going to talk about Django, just to keep the thing going. So actually this is from a Django perspective using Flask. This is a Flask I used to take to school. I was amazed to find pictures of it on the internet, and now I really miss it. I'm going to have to go to eBay. I'm going to do a bunch of random things to do with Flask because I covered all kinds of stuff when trying to replicate the kind of things that I'm used to with Django. And it's obviously it's a very, very tight, small framework. So at Chromium, we had this web service, which is for dealing with malware. So we would be looking for malware hashes, and we have to look them up. And essentially, it's an elaborate cache. And so someone had basically, I assume, got it up in their lunchtime using a CGI script in Python. So it didn't scale very well because it needed a new Python process for every request. So someone ported it to fast CGI, which meant that it still had all the previous problems and also still couldn't deal with load. And so in order to work around this, I had a plan, which was to replace it with Flux. So the biggest problem was database access. So in the meantime, I made what was up there work by just plugging SQL Alchemy gently around the Postgres API to make it use connection pooling. This is the way of solving a lot of load problems. When you're looking at it and you're thinking, why is my database so busy? That's normally the reason is database connection pooling. So, and you can get that for free using SQL Alchemy, but not even having to use the rest of it. And so you kind of end up in looking at it and going, well, I'm going to use SQL Alchemy in the next thing I do. So when doing Flask, obviously I need a database. So SQL Alchemy was chosen, and I put in database migrations right at the beginning with a lend. And being a security company, I tried to design the database layout from a security perspective, which meant multiple databases. And this immediately causes a lot of problems because none of the tools are really designed to deal with it. So you want to keep your users away from your kind of stored data. So if you compromise part of your database, you're compromising all of your databases. And then also you can split off things like personal identifiable information. And that means that you can encrypt it at rest. And so that means you can solve a bunch of security problems by decomposing the database. And with Postgres, it allows you to have multiple databases. In Amazon RDS, you can even, I think you're allowed up to 15 on a single actual database instance you get. And the thing that I found with SQL Alchemy using Flask is there's obviously the Flask SQL Alchemy plugin, and that's what everyone uses. That immediately paints you into a corner when you start thinking, well, how am I going to start using things like worker queues, even microservices to back things up? And you kind of think, well, I still want to be able to access my database, but now I have to bring in all of this Flask dependency as well into these other processes in order to access it. So it's always that all the bits of Flask SQL Alchemy kind of abstract away what you're actually doing. So in SQL Alchemy, you've got the declarative base, which is much like the class-based ORM in Django. And so using that declarative base, then you can build all this. And kind of Flask SQL Alchemy wraps that and kind of hides it from you, but that makes it not immediately applicable across. So this is what I mean by don't paint yourself into a corner. Because you ultimately then need to write scripts as well, where you're going to do offline work, and you might want to write something, so have that kind of Django database access kind of front end. So configuration, it basically works a lot like Django. So you can do the Python one, or you can do a dictionary, but also you follow the same method of doing dev, production, or staging settings. And because Flask isn't telling you what to do, you need to write in the infrastructure to go, hey, I need that particular configuration loaded. And when you're using something like DJUGL, something like this, then passing those parameters in is not always natural. So you kind of having to pass in these extra parameters into your command line to get it started. But it's always beneficial to build that right in from the beginning, because you can get away without building that in Flask immediately. So thinking modular is important in Flask as well. So it doesn't have the same notion of Django modules. It has this notion of blueprints, which are basically, if you imagine your URL routing you normally get with Django, you're kind of splitting that up into separate units, but it's not encouraging you to make all of the bits modular like you would with a Django module. So it's just really splitting up your URL routing. And so what you then need some discipline when dealing with this, and so it makes sense to kind of create immediately a module, an actual Python module to contain all this stuff and try and stop all of this leaking out and all your modules cross-referencing each other. And then you can approach it much like you would anything else, but then that ties into the configuration portion of it still has exactly the same problem as Django, which is kind of your modules need settings, and so your Django settings then fills up with all of this stuff about all of the sub-modules you include. But you can kind of, I suppose, you can put any solution you want in there, because Flask doesn't really tell you what to do. And also, when you use other people's modules, beware of them not respecting it as well. So there's a really, really great plugin which I use for the UI called Flask Admin, which is like Django Admin. So see, I'm mentioning Django a lot, so I'm all right here. It basically builds a blueprint per page, and so you're like getting all of these modules all getting added into your URL routing table. So then you have to sit there and work out how you break these things into a separate module, so you're not taking the whole lot in all the time. And that kind of ties into what I was trying to do here, which was separating the API and UI. And so being a security company, the UI is actually only ever going to be used internally by support engineers and people attempting to run analysis and things like dashboards. It's not a generally consumed thing. And so that needs a lot more database access to do with things like user databases, hence the reason to break down databases. But the API itself, from the company's point of view, needs to access the malware values and a bunch of domain information about bad domains on the internet, and customer information to know whether they're allowed to access it. And then you start tying it down to, do they need read-write access, do they need read access, and those things. So that in this instance, the API itself needs less access than what the UI does. So you can lock that down completely. So if anyone compromises that particular node, then you're not going to expose as much as the other ones. And I should mention, when I draw on the Mac is awesome because it lets you draw ASCII diagrams, which look very, very presentable. So this was for a job interview, but it let me draw basically all web services decomposed to the same things. You need some way of handling this. And so the idea was that we have a bunch of API nodes, a bunch of UI nodes ready to horizontally scale. We use AWS OpsWorks to do that. So testing on it was obviously a thing that I really wanted to build in from the beginning, because we really lacked any of this stuff, because I was kind of handed these Python files. I wasn't even given proper access to the servers either, so I was kind of like, oh, okay, we're just going to have to replace everything with this, right? And the testing in Flask is exactly like Django. You have your client module, but the problem is you must write your own bootstrap. So the bit where you go, right, I need my database, you need to work out, okay, I need a SQLite database. And the gotcha here with Flask is, you go, okay, I'm going to use an in-memory database. But because I'm using multiple databases and I'm trying to simulate that, it means that you actually need it on the file system, because it immediately loses the reference to your particular in-memory database. And then you go, so you put all your fixtures in, and then you go, oh, right, I'm going to go try and access the database, and it's all gone away. So unfortunately, because it messes up performance, then you still have to use the file system. One of the worst aspects of the particular web service I inherited was the load. So every morning at a certain time, 100,000 computers would all ask the same question. And unfortunately, that meant that we caused, I think we managed to answer about 20% of them at most, and then it started sending 500s back, and then the server stopped responding for like 10 minutes. And so I decided to build in load tests for the start. And as part of my tests, I'd written a client class to represent what an endpoint speaking to the API would look like, and I always kind of end up doing something like this. And so I thought, well, Python can work for this. I wonder how many threads I can throw at Python before it baths. And obviously we all know about the guild, so we're thinking, well, we're probably not going to let you do very much. And so I basically took my API client's implementation, and then tried multi-processing pulls. So this is kind of a semi-undocumented feature for doing thread pulls in Python, and I just throw 100 threads at it and then send 10,000 requests into that thread pool. And amazingly, and this is even on a Windows machine, on a Linux machine it's way faster, but on a Windows machine it still manages to do this. It doesn't take my computer offline. And the thing is, you're only doing it from a single endpoint as well. So when you're doing a load test, you go, right, okay, I want all these requests to happen. Using Python requests instead of URL id2 makes sense in that regard, because you can run it in two modes. You can either do a session, or you can run it individual requests. And by running it as individual requests, you end up with the computer making a request, disconnecting, and then it just keeps doing that. And because the thread pool is just constantly filling up with more requests, it's simulating having that many computers attacking. Yeah, the API is always an attack, isn't it? But kind of just keep making those requests. But then you also, if you're using a load balancer, the thing you don't realize is that keep alive is not your friend. So some endpoints then go, right, I'm going to keep this connection alive, and I'm going to keep making API requests. And basically, that starves your load balancer completely. And so you have to run it in then two modes to make sure you can cope with both. So with that, we end, I have two modes to run this particular load test in, and what you discover is you can break Cloudflare very easily. I've seen their Nginx error pages, so they're all Nginx based. And so I'll end with a particular thing that I hit today, which was the Thundering Herd problem. So basically, this thing that I mentioned about all these computers coming online asking the same question, we switched over to the new architecture for 5 minutes through the load balancer. We went, right, okay, we're going to have, we're just going to run it and see what happens. And I started getting all these errors. And as it turns out, all the endpoints still ask exactly the same question all the time. And replacing the software in all of those endpoints is not actually a good solution to this. And what I discovered was that using exactly the same thread pool mechanism, I could just go, right, simulate 1,000 computers all asking the same sharp to go, right, okay, look this up right now at the same time, and use a unique value each time I run it. So then I could simulate the inability for your individual request handlers, the individual servers you've got handling your request, all attempting to write to the database at the same time. So then you end up writing your transaction handling differently as well, because you have all these dependencies on creating their stuff in the database. So basically all of the endpoints all decided, okay, I want this number, they'll come back with an answer, and they will attempt to write into the database at the same time. Because they all said, is it in the database? No, it's not there. I'm going to go and do it. So, yes, that was, but that meant that using the particular load testing stuff done, we could solve this. And and one more thing is what this also showed us was doing database connection pooling can also be dangerous, in that Postgres creates a process to handle each connection to your database. Each process uses about 6 megabytes. So then you can do a kind of rough figure of how many connections you can have per instance. And because I'd split the database into 4 databases, you need 4 connections per thread to keep the connection alive. And then you go, right, okay, well, I've got how many? 8 handling threads per endpoint, so already up to 32. Okay, now I've got 8 servers all doing this as well. Then you can see how the number of connections you have going to your database mounts up. And what you end up with is a huge cascade failure at that point, in that your new request can't create connections to the database, and everything starts 500. And that's why load testing was quite important for this, because although it's not a very elaborate web service, it needs to stand up in those particular instances. Right, anyone has any questions? So I did argue that the entire architecture was essentially a proxy for an upstream service. So the thing is that this malware detection, this particular malware lookup can change over time. And what I'm discovering is that I've collected a load of values that I know the answer to, and they're changing at the rate of about 1 a day at the moment. So I'm having to go shuffle things between columns in order to keep these particular tests not failing all the time. But they're kind of, yeah, when you end up in that situation, you can't have it completely static. Yeah.
Why didn't you just use Django?
I went, oh, it's just an API. I don't need all the Django. And everyone keeps telling me how good this is compared to it. And what I've learned is that I really do like my crutches in Django. That's one of the things. And actually, the ORM in Django is a lot easier to digest than simple out. Simple alchemy can be miserable to set up, especially when you're doing multiple databases.
Was it worth it?
Was it worth it? It works. It works. So that's my main measure. So in the morning, I don't have to worry that all the servers are going to catch fire and I hear sirens in the distance. Helicopters falling out of the air or something like this. But it does scale up to the ultimate, the number of requests it needs to. You just scale it up to it was definitely worth it, especially if you ever saw the original CGI script. So I'm sure someone did it in their lunch.
Good stuff. Thanks very much, Joe. We've got one of the Potato's very own now, so we've got Ola going to come and talk for us. So I think what we're probably going to do, guys and girls, we're going to do one more, and then we'll sort of grab a quick sort of 5-10 minutes, so grab a beer and a slice of pizza probably. And then we've got 3 more sort of following that. So yeah, last one, and then we'll grab a quick break, okay?
Hi everyone, so I'm going to do a Django admin talk with some kind of tricks and tips you can use to make your admin better. I gave this talk at DjangoCon Europe last year in Cardiff, so if you've been there, you're probably not going to learn anything new, so you can go to the kitchen and drink some beer or enjoy our pool table. Anyways, I'm Ola, I work here at Potato as senior Django developer. I also organize a couple of Django things. I organized DjangoCon Europe a couple of times, and Django Girls, and the Django core team. And I also in the DSF Code of Conduct committee, and I organized Django Under the Hood, which is coming this year in Amsterdam in November. So I recommend it. So today, admin. At DjangoCon, I gave like a longer version of this talk because obviously we've got a very short time here. But at DjangoCon, I also talk about, so here I'm going to focus on the middle part, but at DjangoCon, I also spoke about like how Django admin actually works, how it's built, and a little bit of a kind of deep dive into the internals of admin. You can find this stuff online if you're interested. I also talk about the future of admin, but I'm not going to talk about this now. So we're into the middle part, which is, I think, the best useful one. So I'm kind of going to show you, so the example I'm going to be using is Django Girls website. Django Girls is an organization I started with Ola, who is also working here at Potato, that teaches women all over the world programming in Python and Django. We do like one-day workshops, and it's organized all over the world. And we have a Django-powered website that allows people, organizers of our events, set up their page on our website very quickly and manage it for the Django admin. So we didn't have much time to build it because it's kind of grew very quickly, so we used Django admin as our base and kind of expanded on top of it to provide them a bit more nicer interface to manage their website quicker. So for example, on the left you can see the usual Django admin. We are using Django Stud, which is a package you can download from the API, and it kind of gives you a nice sidebar that you can configure, and nicer search, and kind of everything looks a bit and it's more useful. And you can access things quicker, and I think that's what's best about it. So I'm not going to explain you everything about the admin here, but here are some of my my most favorite options that you can use to set up your admin. So the first one is actions on top and actions on bottom. So usually in admin default, you usually just have the actions bar, just this bar at the top, right below search. You can always, in default, it's always only on top. And if you've got lots of things and you check fix on that, and then you want to apply actions, you need to scroll back up. So you can always turn it on at the bottom top. Just quite a small, tiny feature that's really useful. The other thing that I like are field sets. They require a little bit more work because you have to actually think about how you want to structure your elements, but you can do stuff like this. So that allows you, so I've got one field set that is closed and not visible in default, but also there's one that you can add a description to, which kind of makes this whole field pop out a little bit more. So, so people who are using the admin know that this is something they should focus on and read the description and turn it off or on if you want. The other things is list display links. So this actually allows you to, in admin, always the first column allows you to click to go to the edit page. And list display links allows you to specify the fields that should be clickable that will get you to edit page, which is quite useful because the first one not always actually says what it is. Like, it doesn't always kind of give the impression that this is something you click to edit. The other thing I've got is list editable. So this edit table allows you to specify a field that should be editable on the list of elements, of objects. So this is, you can see the inputs here in the fourth column. This is quite useful for stuff like positions, and most of you probably seen that before. The one thing worth mentioning is there is a ticket in Django Code Tracker open for 6 years now that suggests that that probably shouldn't be recommended to use if you've got many users editing the same list, because it can very easily override changes or even save like wrong values for the wrong objects, which could be potentially quite dangerous. So it can be used, but should be used carefully if you know what you're doing. The other thing is radio fields, which is something I didn't know for a long while, but this allows you to replace the select list with a list of radio buttons. So this is quite useful. I think this is going to be checkboxes if you've got multiple choices. But I think it's quite useful if the list is always quite short, and you know it's not going to grow too much, and it's just, I guess, takes less time because you don't have to click to review that there is something there. And then the other one is save as. So this is this one at the bottom. If you set it to true, there is another button on the actions button bar that allows you to save as new. So you can click on edit something, edit an object, and then you go back and click and have another option to save as new. So this way you don't edit, but you've got the whole form pre-filled. You can change something and save as a new object, which is quite useful, and I think lots of people knew about this. At least I didn't for a longer while. And the last one is the show full result count. So this allows you to basically, so in default this is turned on. So when you see your list of objects, you also see the count of all the objects for this model. This allows you to turn this off, which is quite useful when you work in no SQL database. This is what we usually work at Potato as we deploy a lot of things to Google App Engine, which is using a data store, and don't really want to count that many things. So this is quite useful to turn off, and it doesn't slow down your page if you've got lots of objects. So this one is nice. Okay, so these are like the default options in Django that you can turn on and turn off and use quite easily. But other than that, we can also hack admin a little bit to provide a better user experience. So in case of Django Plus website, this is a page for like an example event. I think this one is in Budapest, so I'm Hungarian. But we wanted to provide users who are accessing the admin to only see their own event. So if there's an organizer in Budapest, she only sees her event, not event from London, Warsaw, etc. So we implemented some more advanced permissions in the admin so that organizers can only edit their own events. So here's how the admin looks for super admins. So I can see all of the events. Yeah, we are using Django Suite, but then if you want to have Justyna and Anya who are organizing Cardiff only see Cardiff event, we do quite a simple thing to override in our event admin definition. We can override the get query set, and then we can specify that if request user is a super user, then return all of the events. But if it's not, then only filter where the user is actually belonging to the team. That was super quick. And then Justyna and Anya actually only see an event in Cardiff. There's one gotcha here, that if they go to edit a Cardiff event, they see a page of all available. They've got in the form of website, they see all of the available pages. So for other events. So unfortunately, you also have to apply this limitation to get form. So in all of your event admin or other admin definitions, you also have to override the get form in a very similar way. So you also have a query set, but on the field that needs to be limited. So you kind of go here. If the request is not a super user, then you need to limit the query set to only provide those fields for the user that belongs to that team. And that's it. And then Justyna and Anya can only see this Django Girls Cardiff event in the list, which is quite neat. So we implemented it kind of all over our admins. And this way, if they only belong to the team, they only see one event. There was also another problem that came up, that organizers were, after the event was over, we wanted them to add another one, not edit the old one, because we were losing track of the events that were happening in all of the cities, and this is just not a nice way to keep an archive. So we wanted to kind of make sure they cannot do this, because we told them what to do. So we took advantage of the read-only fields, except we only wanted to have them read-only if the event is passed. So we override the get read-only fields method that actually fetches all of that fields that should be read-only, and if the event was passed. So here, if it was not upcoming, then we would just return a list of all of the fields on that model. This way, we wouldn't have to specify them one by one, but we can just fetch all of them from the .meta attribute. And this is, I think, a new addition in Django 1.8. Very useful and allows you to just return a set of all of the fields on that model. So to that, and then when Justyna or Anya would visit their edit page for this website after the event, they would only see read-only fields. They couldn't edit anything. I think this is the last one, and we had this case that we needed to contact all of the organizers of an event, but it took a little bit. Like, we had to click on the event, go to the edit page, and then find them on the list of all of the team, and it was just quite annoying to have to retype the emails and stuff like this. So we came up with the idea to actually list it on the list of events. So right next to the event name on the list of objects in the event model, we wanted to have a list of all organizers with their email that we can just copy and paste into Gmail. So you can do this quite easily in admin by using custom method fields. So as you can see here, in the list display, the get organizers was not actually a field, but it was a method. So if you specify a method, you pass a method name into the list display list tuple, and then you create the same method, the same name on the event admin, on your model admin instance. And then that basically gets instantiated every time there is a new event role rendered on the event list page. This is quite useful, although you also have to kind of keep in mind that this is gonna generate this is gonna invoke this function whenever the row is rendered. So if you've got lots of rows and you're doing some database heavy operations in this can actually just die very quickly. But what we did, we listed the whole team, added their emails, and then displayed it in the list. So this is how it looked like. Right next to the event name, we had names and emails of all of the organizers, so we could just copy, paste, and that was done. And you can do this for all of that. You can do this for images, you can do this for links, And this is quite useful. So this, we use the same way to display the status of the event, whether it's passed or not. So we can just quickly take a look or sort by it. And we also use it to display images on a list, for example, sponsors or coaches. So I can just match the photo and I have to click on it and do this one more page. What else do I have? Yeah, so this is the example when we use it for photos. Tomek is, I think, somewhere here. Yes, I used his photo everywhere. But yes, so this is how it goes for images. One thing you've got to keep in mind if you're putting HTML in it, make sure to do the allow tags true. Although I think that changed in the recent Django version. I think 1.9, you now need to do mark safe instead of entities deprecated. I think I actually did that change in Django. That's why I remember. But allow tags I think is now deprecated, and you have to do mark safe, which you can import from Django utils HTML or something like that. Yes, so you can do that. The last thing, I have one more thing. It's custom actions. So, so you know, this action bar is usually only delete multiple things in there, but you can also use this to perform other actions. For example, we had published those selected events on the homepage. This homepage was like a Boolean flag. So this is something you can do in admin. Again, you just create a simple method on the event admin or your model admin definition that gets requests and query set, and then updates the flag on the query set. You can add a description to it, and then you have to also add it to the actions list on your event admin, which is default not there. And that's it. And then you kind of get to this very nice list. You click, and that updates all that is on homepage flags. Yeah.
Do we have any questions, guys?
Got a really small question.
Yeah.
Why do you return a set? Why do you return a list into a set when you return it to the event?
It wasn't so some. Yeah, I'm not sure. I don't think there could be any duplicates on it, but I guess I just wanted to be sure. I don't know. Yeah, I don't think there will be any duplicates on it. No idea. Yep.
Is there any work to improve the performance of Django admin? So where you add extra fields, does it create a new query for every row?
Yeah.
Is there any proposals or any work to improve the performance on that?
I don't think there is any work on admin. So admin is quite in a weird state of people wanting to have new things in it, but no one really wanting to work on it. So if you want to work on it, there is probably a ticket for it. Also, the code base of the admin is not really, so it's quite hard to expand at the moment because so the code base is quite old. It was created back when Django was created and wasn't really improved since then, except the recent CSS change. But it was a CSS only change, and it's quite difficult to expand on it. And I think like everyone who goes to improve something small in admin, and they look at the code base and like, oh, I need to rewrite it. I need to rewrite it all. It never happens because it's quite a big project. So it's quite a number of people who are trying to improve it, but not really succeeding because of this rabbit hole of really quite difficult to understand or just quite ugly code, I guess. Yeah.
Is all of what you showed working on a normal admin?
Yeah. Everything from that is working on the normal admin. I think it's that like so the Django so basically gives you a nicer design of that, or maybe you don't like it, I don't know. But like it moves the buttons to the right, so you don't have to scroll down if you've got a long form. It gives you the sidebar on the left. This sidebar here, which you can customize, and you can also add some external links to it. So it's quite useful, but everything I showed can be used on normal Django admin.
Perfect. What we'll do now is we'll take 5 to now. So if we say 10 minutes, just conscious of the time for everyone. So if we grab 10 minutes, and when we come back, Mr. Tom is going to do his introduction to the Django REST 3.4. So yeah, 10 minutes, 5 parts, we'll be back and ready to go.
But I muted the stream for now.
So used to structure. I really, yeah, that's good. And okay, guys, I think that's pretty much everyone. The kitchen, but we'll crack on. So as I said, we've got 3 more talks. So first up, we're going to go with Tom, and he's going to introduce his REST framework.
So my name is Tom Christie. I'm the author of Django REST Framework, which I think probably most of you will know about. I wanted to talk to you today about good band.
Oh, that's my fault. Sorry.
I wanted to talk to you today about the latest upcoming version of REST Framework 3.4 and some of the functionality that's in there, and also a little bit about what I'm planning to come after that. So this is my lo-fi version of presentation, minimum viable product. So, right, there are 2 big bits of functionality coming up in 3.4. It is focused on schema generation and client libraries. Okay, so schema generation. Schemas, API schemas, are a description of the API that can be used as a tool either for generating documentation, for testing purposes, or also potentially to drive dynamic clients that can then interact with your API. So having built-in schema generation is one of the things that's coming to REST Framework 3.4, and I'll start off by describing how we go about this in a way that allows us to output to multiple different schema formats. So there are lots of different schema formats out there. There's the big popular one is Swagger, but there's also API blueprints, JSON hyperschema, and we would like to be able to support all of these different schema formats without too much work on the part of the developer, depending on your requirements. So what we do in 3.4 is we have an internal representation of the API schema, which is a document representation in something called Core API. So Core API is a document representation specification for describing APIs, the interactions that you can perform on them, what are their endpoints, what are the descriptions of the different parameters that you can use, what are the different methods on each of the endpoints, and so on. And there is a format-independent internal representation that Core API describes. So in REST Framework 3.4, there is a bunch of API introspection that we've built into it, I've built into it, that can inspect the API that you've built and return this internal object called the core API document. That is not the schema format itself, but is an internal representation of it. Once you have one of these core API documents, you can then write it out into lots of different formats by using different renderer classes into whether it's Swagger, JSON Hyperschema API blueprints, core JSON, which is a schema format designed to work alongside core API, which allows you very easily to do things like add Swagger UI to your API. So Swagger UI is a API interaction and inspection front end of people's APIs that works with any API that exposes the Swagger format. Okay, so we'll be releasing at the moment in 3.3, there's a Django REST Swagger package. Essentially what we're doing is taking all the sorts of things that does, building it into the core of REST framework and building it in a format independent way that allows you to expose lots of different schema formats. Not only schema formats, what it will also help with is being able to automatically generate and serve up HTML documentation for your API that is based on introspecting the API and then serving up that documentation directly. So I'll just give you an idea. There are a few different ways that you can do this, but I'll just give you a bit of an idea what it looks like when if you upgrade from 3.3 to 3.4 and you wanted to add this. So this is looking at the tutorial project. I've taken the tutorial project at its endpoint, having gone through everything. I've upgraded to 3.4, not yet really, to master. And here's the API as it is at the end of the tutorial. And you can see the root endpoint serves up either the browsable API or JSON responses. Now, what we're going to do is say we'd like to generate a schema. So that's what we do. And just by adding a schema title into the router there, we will automatically get have a schema format for the API available that can be accessed by making an HTTP request with the correct accept header to the root endpoint. Okay, and you can use core JSON, you can use Swagger, or you can use any of these other formats that we talked about. So, oh yeah, I have to. As I say, there's a few different ways you can do it. So the router approach is your zero configuration. I just want something really quickly to get me up and going approach. That's your, I'll put in the title, maybe I'll add an argument that says which renderers I'd like. If you want to be more, you can kind of gradually get more advanced about that. So there's a schema generator class. If you want to be able to customize a bit more how the API schema is built based on your API, where you instantiate one of these and you use it to generate the document object and you return the document object from your view, making sure that it has schema renderers on it. You can be entirely explicit in your code base about the schema that you want to generate by writing a core API document in the code itself. Or you can take the approach of saying, okay, I have a schema file for my API. I have a schema file in API blueprint, say, and I would like to read that in, turn it into a core API document object, and return that from the view and allow me to serve it up either in its original API blueprint style or in some other schema format. So that's the schema generation side of it. One of the things that I'm really excited about that allows you to then do is driving dynamic client libraries and driving dynamic tooling that can interact with the API. So we'll talk about that now. So this is on the client side. This is on the client side. We've got an API that's exposing a schema format. We'd like to be able to interact with that API using the schema format as the description of what are the available actions I can take on that. So what that gives you is a more meaningful interface that you're interacting with. It allows you to introspect the API more meaningfully. If you're writing client code that interacts with it and you're using a client library, the code that you are writing is more explicit about what is it actually doing, rather than make this HTTP request to that endpoint with this encoding, blah, blah, blah. So we're exposing a schema. The client goes and fetches that schema and converts it into a core API document. Once you have the core API document, the user of the client, whether that is somebody interacting with it via a command line tool or whether it's the programmatic client, can interact with the document itself, which manages turning this is the representation of the API into, here are the actual HTTP requests that need to be made. So I'll give you an example of what that looks like. So what we're going to look at is using the command line tool to interact with the API. So we've installed core API, and we now have the core, I hope you can see that well enough. We now have the core API command line tool installed. So we use the get command to go off and fetch the representation, and we now have this documentation in front of us. At the moment, it's showing us the snippets and the users, and we can ask it to, we can start to interact with it by, oh. Well, at least it's not live coding. It would be even worse then. But. So here we go, core API. We say action. We want to interact with the API. We point into which action it is we wanted to do. It's, sorry. It's in the snippet, it's in list. You can also have parameters on the action. So for example, snippets retrieve takes a PK parameter. So action snippets retrieve with PK6, and that will just give us back the code snippet number. So what else? At the moment, we're looking at the API and we haven't got any edit actions in there. That's because we're not authenticated at the moment. So we can also authenticate with the core API client. So here we're going to use basic authentication. You can use other authentication styles for this. And we add those credentials in, say we want to use those credentials for this host and this host only. And then we can reload the API and it will give us the authenticated version of the schema. And at that point, we've got all of the edit type actions available to us as well. So core API actions, snippets, creates, well, you can read this. So we can create a snippet that is our little hello world snippet. Actually, thinking about it, I should have also given you an example of saying, in this example that we're happening to look at, it's an example of a paste bin API, where you put in code snippets and you get back HTML highlighted versions of that. There's also, one of the actions there is highlight, and if you go off and use that action, then the data that's returned to you is not JSON, but it's instead the HTML of the highlighted snippets. So, I know that I'm just skimming over all of this stuff, but you know, this is the taster. All of the release notes, you know, and documentation goes into this in plenty of detail. So, other things that will, oh yeah, okay, long way around. Alongside 3.4, that will include the command line tool that you've just seen, but also a Python client library so that you can interact with your API programmatically as well. This approach also kind of opens up a whole bunch of possibilities for building kind of more advanced tooling to interact with your API or inspect your API. So you could imagine, for instance, a native client that you might have on iOS that you could use to go and inspect and interact with your API. Other things that are planned for this, so client libraries in other languages, in particular JavaScript, but ideally also Swift, Java, you know, maybe Go one day. Hypermedia, so I'm starting with API schemas, but Core API also allows you to describe hypermedia responses and interact with your APIs in an entirely different kind of modality. And I don't think that, I think that the tooling that Core API gives you will allow you to build different kinds of hypermedia applications that people aren't really building today. When people use hypermedia today, they're really using a very light kind of hypermedia. What you need in order to make hypermedia powerful is client tooling that has this network effect of you build some great client tooling and it can suddenly work with any of these hypermedia APIs. Anyway, so I think it'll let you do some quite interesting things there. And also real-time support. I have some very clear ideas about how real-time and WebSockets in Django will feed into this and give you real-time APIs that you can also interact with. So, oh yeah, here's the money shot. So I've quit my job to do this, which, you know, isn't something that I do every day. And I need company support if this is going to work. Okay, it's not a lot of money. You know, the beautiful thing about a collaboratively funded approach is that each company only needs to put in small amounts in order to make it work, right? So the basic tier is £35 a month. I would hope that, you know, you folks will go away today and try to sell this to your companies, because I think that the win of having somebody working on this sort of stuff full time will be enormous for the project. Even when I was working on the Kickstarter, I was only ever working at 50% time. Now I'm on it full stop. At the moment, we're 45% of the way there. That's pretty much just based from the launch. I'm pretty optimistic that we'll hit 100%, but we'll see. I think it's also important that I'm very transparent about, you know, the finances of this. If I'm asking companies to give me money, I need to let them know, you know, what rate are they paying or how much are they expecting. I'm aiming for my baseline for being able to say, okay, this is a viable project and I don't need to seek freelance work. £48,000 a year revenue, not salary. So this is not some grand, big money-making scheme, but I think it is a viable approach to building a business. I think it is in the community's interests. The other thing that I would say that is important when you're going out and selling one aspect, one way that you can talk to your companies about what's the benefit. I want to work for your companies full time. I want to work for your companies full time, but there's one con and there's one pro. And the con is I only want to work on open source stuff, and I'm going to say what I think is important, and that's what I'm going to do. The pro is you only need to pay me £35 a month. I'll work for your company full time. Okay, so anyway, if you think that, oh, wait a minute, damn, I meant to do this the other way around. I meant to say at the very start, could you folks in the room, could you put your hands up if either you or the company that you work for uses REST framework in some capacity? Okay, great. And can you put your hands up if your your company or yourself is currently sponsoring REST framework. Right.
I've asked. I'm not sure whether it's come through.
Oh, you have? Okay.
But yes, we do. If it's not, I'll double check.
Okay. Oh, you've asked you haven't asked me. Okay, great. Phew. I thought I was missing something there. Thank you. Yeah, see, that needs to change. You know, it needs to be, you know, you get the picture. Anyway, if you think that you're interested in helping your company sign up, please just drop me an email or send me a little ping on Twitter, just so that I know who you are and that I've got you on the list, and so that we can talk. And, you know, if whoever's in control of the finances wants to have a conversation about this in order to be able to make a good assessment of whether it's good for their business or not, that we can have that conversation and decide based on that. Yeah, so thanks. Sorry, you know, it's a pitch, I know, but, you know, it's in all our interests, and thank you.
I'm sure there are a few, but has anyone got any sort of questions initially there?
So my question is about your usage of Swagger. So effectively, Swagger becomes like a secondary artifact that you generate from your API. So for me, it's the other way around. I write Swagger and then I make sure that my API matches. So how those two visions actually?
Okay, so you can do that. You can do that. You can, well, either you can do what you're doing at the moment, not worry at all about using core API.
I could probably use that. Not worry at all about using core API on the server side. If you want, and you're exposing a Swagger specification, whether it's a Django REST framework project or not, that means you'll be able to use the command line tool with that API. Swagger, you know, whatever the server side is written in. So that's one option. The other option is to write your spec in Swagger, have your view read the Swagger file, load that into convert that into a core API document, and return that core API document from a view. What that then gives you is the being able to serve multiple different types of schema formats, and probably more excitingly, when we get there, you know, really nice documentation based on your Swagger spec that you've written by hand.
Yeah, well, so our point is effectively to have Swagger in the middle between a single page application written in Angular and the backend written in Django. And that Swagger is shared, so our guys who write JavaScript, they create fake APIs based on the same Swagger that then the Django developers use as creating fake clients to actually test the APIs.
Yeah, so write your spec first, like you're doing, absolutely, and serve it directly, you know, from your API. You don't need to use core API. So I hope that for organizations already using an API schema, that the client tooling will be quite interesting, especially when the JavaScript client library comes along.
You showed an example where you authenticate the client and then you got a different description of the API.
Yeah.
And I was thinking that for supporting some more static languages like Golang, you may be able to get a code generator, but if the API description changes dynamically,
so
if it's dynamical, or it's something that you get a description and then you filter what you can do from that?
I don't think that will be a problem. I kind of thought that we'll get there when we get there, but if you consider it from the point of view of, well, what are browsers written in? Well, browsers are written in static typed languages, and they cope with, so, but yeah.
You offer a dynamic approach that typically APIs that you make with code generator a bit cleaner.
Yeah, it's a different, yes, it is a different style, yes, that's true. Yeah.
So the notation should be dynamic, not code generation based to work properly.
I think, yes, I think that's where the big win is. I think that's where the big win is,
Hi.
how does your latest work on 3.4 relate to what's being done on other languages or libraries? Do you take inspiration from other projects?
Anything in particular that you're thinking about?
Or,
well, I suppose one thing I would say is when I started off this work, I wasn't thinking about API schemes at all. This was always started off from hypermedia and trying to describe APIs in a more meaningful way. And it's kind of become clear that, well, actually, a subset of that is using an API schema. And all these other people have gone off and built all of this other tooling around it, and it fits in really well with the type of APIs that already exist. You don't need to change anything. All you need to do is add a schema to your existing API. So yeah, all of that schema ecosystem has definitely changed what I thought is important about this. Yeah, that.
Okay. So I just want to ask you about hypermedia because this is really the interesting bit about exposing RESTful endpoints, right? So you just mentioned that the future is actually going to bring us hypermedia. Do you have maybe a post, or do you have somewhere where someone could read? What do you understand by bringing us to the hypermedia utopia? Because we've heard about it for years now.
The only way that I can describe that is by writing a detailed tutorial. Ideally, the plan for 3.5 is to have a new, like, advanced level tutorial that walks through building a very different style of API in the hypermedia style.
Oh, sorry, we've got it. Yeah. Sorry, guys, we've got 2 minutes. I appreciate we could probably be here all night talking, but we've got Anna also from Potato next, and then obviously one more just to follow. So I appreciate it.
I'll fix the mic.
Is that all right?
I don't know how to use it. Right, good. Tech stuff. So hello everyone. This talk is called To Mock or Not to Mock? That is the question. And obviously it's going to be about mocks and tests. And it's a treatise narrated by me, Anna. I work here at Potato. So if you have any questions about Potato or about mocks as well, you can come up to me. I actually gave this talk a bunch of times, so Potato is already bored, they don't want to hear about mocks or anything, nobody is going to listen to me. I gave this talk also at DjangoCon Europe and at PyCon US, one version or another. So I'll try to make this one faster, maybe a little bit more interesting, I don't know. So right. I hope everyone agrees that tests are important, right? There are no problems there and no objections. And as William Shakespeare said himself, thou shalt write tests. So let's start with the beginning, which is the chapter 1. It's actually introduction. And I have a question. So maybe we could skip this one because it just explains in very generic terms what are mocks. So I'm reviewing what is a mock, what is a magic mock, and what is patch and how patch works. Do you feel comfortable with all those terms? And maybe we could just skip it. Yeah? Maybe somebody doesn't know some of the things. Right, okay. So very, very brief. Mocks are special type of objects that simulate the looks and behavior of real objects. And a very simple analogy is that the real object that you use, that you have in your application, is like a Swiss Army knife, and it has all these dangerous features. Whereas a mock is just a plastic toy knife. Well, it lost all of the gadgets that the Swiss Army knife had, and also it can't even cut. So it's basically fake. It can't do the job that the real object can, but it just pretends to be the one. So ta-da, we have the unit test mock in Python 3.3, and we need to install mock library for Python 2. People like us at Potato, because Google App Engine, hello. Right, so there is mock. How do we use mocks? So we create a mock, and then we can say that an attribute on the mock has a specific value and is going to be stored in there so that we can access it afterwards. If we don't specify what is the value of an attribute, then it's going to be just another mock. So we can just recursively create mocks over mocks. And the difference between mock and a magic mock is that magic mock provides default implementations for most of the Python dunder methods, which are like this magic methods __ something. And finally, patch, which is probably the most important bit, because it's very flexible. It can be used both as a function decorator, a class decorator, or a context manager. So there's plenty of flexibility. And the important bit about patching is the namespacing, because here's an example where we say that we patch rainbow.pony. Pony is a class somewhere in a module called rainbow. And the interesting bit here is that Pony was actually created, specified in absolutely different place, like in creatures.py, but it has been used in rainbow.py because it was important. So when we patch, I forgot about this slide. So basically, when we patch, the mantra is that we need to mark where the object was used rather than where it was created, where it came from. That's all we need to know. And now the whole talk is split up into two parts. So one is the good mocks and one is the bad mocks. And we're going to get to Django at some point. Like, don't worry, it's quite generic. It's also like very just Python and test related. So let's start with the good mocks, which is the first chapter. And let's start with the system calls. I have like a couple of examples that show how we can use mocks in a good way. So here what we're doing, we're patching the OS environment dictionary because, well, we don't want to set those things while we are in test, so we can just mock them. And the interesting bit here is that this is actually taken from a real-world project. It's from Kiwi. Somebody used the cross-platform framework. So it's basically using the environmental variables to specify what kind of platform is that and then do assertions on that. So what about the streams? We don't want to deal with std out and std in, so that's why we can mock it by using mock patch and then mock the sys std out and to replace it with a whole different callable, which is a string IO. I'm going a bit fast here, but I'll just pause the slides and you can take a look at those examples. And also, this is also from a real-world open source project, Scrappy, the scrapping and web crawling framework. The interesting thing is even today, I actually had to do some communication with a third-party API over the network. So I actually mocked the URL fetch, which we're using from the Google App Engine. So here the example is that we are mocking the request URL open, and the example is taken from Wagtail. Really cool CMS. I think Potato is using it. Cool stuff. Don't tell this to Django CMS people. Right, the I/O operation. So here's a very big speed improvement that we can get by using mocks. And what we're mocking in this case is a whole object, which is the data loader, and actually the method on it, which is called the get file contents. And internally, it is using JSON loads. It's mocking it on a more higher level. And the example is taken from Ansible, which is an automation tool. I'm going fast. So another interesting example is the clocks, times, and time zones. So here is a very interesting example where time sleep is patched. Well, because obviously when we run the test, we don't want to spend seconds while something is happening. In this case, I think what it does internally, there's an exponential backup. That's why it's using time sleep. And the example is from Bo2, which is a Python library for Python interface to Amazon Web Services SDK, which is really cool. And the last one, most obvious, is the randomness, the unpredictable results. Because there is no other way. We just have to mock it. The example is taken from Sentry, a tool for error logging. So quick recap on what were the good mocks. So those were the system calls, streams, networking, IO operations, clocks, time zones, and unpredictable results. And a quick recap, why do we consider them good? Because some people like unit tests to be very, very fast. I found out actually from the more of a JavaScript community is that they actually have a runner which checks for the changes that you have made to your test, and it runs the test automatically. So just like there's a continuous loop. You don't have to go to, in Django, I would normally I would write the test, I'd finish writing the test, and I'd go and I'd manage that by test, and I would run the test. Some people just have insanely speedy tests. So the second one is that to make impossible possible, again, talking about the random functions and excluding external dependencies that we might have. And so in the same way that the first talk that we had tonight, Vlad mentioned that he would mock a lot of the things. So this is one approach of dealing with various, how you're going to write your test. But I've also met a lot of other people. So when I was going to the conferences and people would tell me, it's like, oh, you're a speaker, what are you going to speak about? And I'm like, oh, the talk is called to mock or not to mock, that is the question. And they would say not, instantly. Some people just have this instant thing against mocks. So the third chapter is going to be why potentially those mocks can be dangerous. And I'll have one example. So this is where we got to the Django bit, this is a test. What we're doing, we're patching an object, the pony object that we had from the very beginning, and we're mocking the save base method. Then we're instantiating a form, we're passing some data, we're passing the instance, we are checking if the form is valid, then we're calling the save, we are asserting some stuff on this saved thing, on the saved instance, and then we're doing mock save assert called once. So right, the big question here is that what kind of problems can we identify in this specific example? And the most obvious one, and it's not even related to tests, it's actually just a generic thing that happens sometimes to our test spaces, is that we have this line which says assert true, save pony age free. Well, it seems ridiculous, it should be assert equal, obviously, but it's there because maybe somebody just did a copy paste and then changed some things and never paid attention to it. And it's like people rarely go to refactor their tests, so it's a bit dangerous. But there is one other thing which is directly related to mocks, and it's this line. And the thing is that I'm saying I'm asserting that this method, the save method, was called once, but I mean, what if I say, was it called twice? And I'm wondering if it's going to run without errors. Actually, yes, it will run without errors. And I'm wondering what if maybe it wants to make me a sandwich, and that'll be all right with it as well. The reason why this is happening is because mocks create all attributes and methods as we access them. And this is basic mocking that we need to keep in mind. But the problem is that we don't like going and checking APIs or documentation, so we can also make a little typo, and the bigger problem here is that this kind of things can propagate a really long way. So obviously the mock save is not being checked if it was called once or twice, and this kind of sucks. We need to know if we're testing our thing right. So here are a couple of solutions. Going back to the code, so the original intention was to use this method, which is assert called once with. This method indeed exists in the mock API, and it does what it says. The previous one didn't. But this is prone to error, so just don't use it. There's a simple alternative. So use mocksave.callCount, which is an attribute, and then check if it's equal to 0 or 1 or 2, And we can't do things like this because, you know, if we make a typo, use a different attribute, it will not work, which is a good thing. And the third solution, the queen of them all, is the TDD, obviously, because one of the mantras of test-driven development is that we need to see the test fail before we do anything else. And a non-failing, if the test doesn't fail, well, that's red alarm, like instantly. And if you're interested in TDD and you like Django, I guess everyone likes Django then. I'd recommend a book by Harry Percival, which is Test-Driven Development with Python, and it's actually based, so the whole book just goes through one whole example of how would you TDD a Django app. And if you go to chapter 19, it has some things about mocks and a very interesting concept called outside-in TDD, where it says why would you want to use mocks in some specific cases, but it will tell you about the risks of those as well. Right, so let's keep the second solution, which was the call count. We're not going to write TDD, well, not right now. There's a bigger question here. Why do we call pony save, why do we actually mock the pony save base method? And one of the reasons that people who usually are pro mocking will tell you is that it's going to be faster, because even so using mocks is going to be way faster even compared to the in-memory database of Django. But is it a good idea, or is it actually a bad idea? As being Django developers, we know various things that can happen. For example, we can have various hooks performed on the model save, and we can have signals, and what if the model changes and then the form doesn't keep track of the interface changes? So all sorts of things can happen, and we will actually never know if what will happen on the save, because we are actually never calling it. And here the bigger problem is that no one will review or refactor the tasks that already exist in our projects most of the time, so because business will say there is not enough time for that, or it's just not a priority right now. But everyone will trust a hefty number of passing tests. So what happens is that, well, if the test pass, then yeah, why, no problem, let's ship the product, it's going to be okay. And what I'm trying to say overall is that maybe that test wasn't that bad. Maybe it was just incomplete. And Django as a framework is a very complex thing. It's like a rainbow cake with many delicious layers. And those layers are interlinked with each other in one way or another. So when we want to test those tests, how those layers operate all together, we should write integration tests to assert our understanding of the contracts that exist between those layers. So at the same time, it's perfectly valid to unit test our business logic. And if it happened that our business logic was in a form, which is perfectly valid, we can use a mock for that. But please, please, please provide integration tests that will transcend through all the layers of Django to perform one single action and see how the form validation fits into the big picture. And especially because Django is providing easy tools to write integration tests and even recommends them. So the takeaway, unit tests and mocks work okay, unit tests are good, integration tests are good as well, but just don't use mocks in your integration tests. So since most of the time we build on top of third-party code, which is the case with us building apps with Django, there is like one safe rule, which is only mock types that you own, don't mock types that you can't change. And this recommendation appears in the book Growing Object-Oriented Software Guided by Tests. But things aren't that simple, and we'll see why. So there is a very, very thin little chapter in this book about mocks, and it says the following, that if you're using third-party code, is create a very thin layer of adapter objects between the third-party API and your application. And the next step is create a suite of integration tests to confirm your understanding of the third-party code and test this whole cluster altogether so that you're sure that it works the way you're expecting it to work. And if you want to mock something, well, just mock your application objects. But sometimes it's very hard to follow this recommendation because the code that we don't own sometimes can be so intertwined with our app's code by design. Some things can be abstracted, others are way too fundamental. And so the takeaway from this is analyze your code base and use your best judgment regarding the usage of mocks. So this brings us to the end of the story, and I'm out of breath, I think. Not to scare you, but mocks can be dangerous, and they will hide what shouldn't be hidden, and leave with a false sense of security that everything is fine. Thank you.
Do we have any quick questions? You've got one more speaker. So if you guys want to crack on with your questions, we'll get Rowan set up here.
So with the slide that you had where you were testing the form, is there a reason why you didn't mock out the instance as opposed to, because it looks like you're mocking out the form. So I've seen this like back maybe 4 or 5 slides.
Oh, sorry.
Oh, sorry. Go back in. Sorry, it's me being over eager.
So you were mocking the function base save.
Um,
So effectively, it was this is if you were testing the form.
work. Is this one, right?
Yeah.
Where we're mocking, so what we're here mocking, we're not mocking the whole object, we're mocking just a specific method on the object.
Yeah. In this example, it made more sense to mock out the save function on the instance as opposed to the save base function.
What would be the difference between mocking the save or the save base? Because I think save is calling save base.
Yeah, I guess in terms of like save is the public function.
Yes, it is.
Save base is the private hidden. So I guess in terms of this, your mock, you're testing a private function is being called. And maybe some people might say that you're mocking or you're testing the mock, or your mocking might make your test a bit brittle. Like if the internal implementation of Django changes, your test might fail. Whereas if you tested the save, then and they change the internals, then your test will.
I agree. That's a good point. That's the thing that why this example is also bad, because it's intentionally made bad, is that we're leaking internal details of our framework, which is a good thing, which is a bad thing. Sorry, but even though we would replace right now the save base with save method, is going to be equally bad. If this one is like slightly worse.
Because you're still not really unit testing the form. This is kind of testing. I guess it's like a mini integration test that saving the form affects the object.
Yeah, somewhat. It's yeah, I guess it's a mixture of flavors. It's not exactly a unit. It's not exactly an integration. But I've seen this kind of tests a lot, so it was kind of like.
There's a really good article saying, like, I can't remember the exact title, but if you Google for why you shouldn't why nobody's unit testing Django forms, it kind of gives a really good example, really good write-up.
Thank you.
Okay, so a little round of applause. Okay, so final one then for the evening. I appreciate, obviously, we're running a little bit behind, that's my fault, I apologise. But last sort of 10 minutes. Okay, so this is Rowan, so he's speaking from iWalker. Over to yourself.
So hi everybody, so my name is Roman, and tonight I wanted to share my experience of upgrading a Django project from 1.4 to 1.9. So I think what I will present can be really used in almost every project, so if you have to upgrade your whole project, maybe it will help. So let's dive into it. So obviously, I'm kidding, but that's true. if you do that, it will upgrade your Django project. This talk is more about how to upgrade the whole code that is around Django. So just to give you a bit of context for this experience, so I'm working, like I said, in Iwoka, that's a financial company. We're lending money to small and medium businesses, so we are dealing with a bit of sensitive information. We have quite big Django monolithic with a lot of custom apps, 200,000 line of code, which begins to be a quite nice Django project. We are doing some continuous deployment, about 10 releases a day. We have 20 people that are working full-time on this monolith. And let's go back in time. Imagine that we're in August 2015. We are still in Django 1.4. I don't know if you remember a bit the timing of all the Django versions. So I've just given a bit of summary. So what is happening is that the 1.4 was the LTS for Django, which means that the support was ending 2 months, in the future. So it means that in 2 months, my Django version won't be supported anymore. It means that they won't have any more security patches, which is a big problem related to the data sensitivity I was talking before. So if you check this data, then it means that the next supported version at that time is the 1.7. Okay, fine, let's upgrade to 1.7 directly. But if you check, the 1.9 is going out on 1st of December, which means that when this one will be out, the 1.7 won't be supported anymore, which means that at that point we decided to change from 1.4 to 1.8 directly. So as you can imagine, there are 2 major issues to do that on a really big project. The first one is that the upgrade is massive. You have a lot of things to fix. Just to give you a small idea, obviously you won't see it, the bullets, but the idea was to give you an idea of, I've tried to summarize in a wiki everything I was just fixing to be sure that in the future we have any issues, we can just try to find quite easily what changed. So it's half of all the changes I had to do from 1.4 to 1.8, just to give you an idea. So obviously if you are doing this kind of changes, the risk to break something in the whole project is quite high. So that was the first issue. The second issue is, why, let's say that we decide to keep all the developers on 1.4 for now, that is the one we are using, and to work on our Django upgrade branch that will be the one that at the end will be in 1.8. And let's make them completely separate. So let's say I would work on the upgrade for like weeks, because there are a lot of things to fix. And at the end, when we want to merge everything to master, what is almost sure is that there are people that have developed some code in 1.4 that has broken what I've fixed in my branch. So what we decided to do is to have more interaction between my upgrade branch and the version that everybody was using. So the idea was to do one fix at a time. We were fixing something for the upgrade, we were reporting it to master, and we were doing that for each version. So the whole process is like that. For each Django version, I insist on that because there is no shortcut. If you want to upgrade between 2 different versions, you can go from 1.4 to 1.8 directly, but you will have to go through all the release notes for all the versions. So let's just start version per version. For each version, you can read the Django release notes that are really well structured to help you for your upgrade. Just to give you an idea, if you have never read Django release notes, that's a bit how they are structured. So on the top of the release notes, you will have the new functionalities, then you will have everything that is backward incompatible, which is quite important for your upgrade, deprecate features, which will be removed to versions after, and the features that are removed in this version. So the backward incompatibility and the removed features are the most important things when you are beginning to look at upgrading your code. So what is quite good also, if you begin to read the Django release note before doing anything, is that you will begin to put in your mind some things that have been, that have been changing. So, and then when you will run your automatic test or manual testing, depending on your environment, you will think, oh yeah, there is an issue with the ORM. I remember that in the release note they were saying something was changing, so we will match pretty, I would say, quicker all the issues you can encounter. And again, yeah, fix its issues. So to do that, to fix each issue, that was this one fix at a time was causing a bit of problems, because imagine that you are in the Django 1.5 and something is existing in 1.5 and not in 1.4 or in a different way. How do you make things working and compatible between all versions? So for that, I've used like 3 toolbox. Like I've created some compatibility modules. I've used logic of deprecated rules and also documentation. So let's start with compatibility, which is, I would say, quite easy to understand. Before, your code was really in function A. Now your code, so this one is on version, let's say Django 1.4. In version 1.5, the function A is not existing anymore. It has been replaced by function B. How do you make your code compatible with both versions? You just create a kind of compat module that, depending on your environment, will import one or the other function, which is, I don't know if you are curious about that, but 6, that is the Python compatibility module between Python 2 and Python 3. There are a lot of things that is dealing in that way to be sure that when you're importing a symbol, it will always find the right one depending on your Python version. So to give you some examples of how the compatibility module doing. So on the top, the transaction management that's changed in 1.6. So what is happening? Before we were using commit and success, now there is an atomic. Just careful on this example, it's not completely equivalent. If you are really curious on transactions, there is a really nice talk in the DjangoCon 2013, I think, it was the one on the circus. There was a talk from Émeric Augustin, which was talking about transactions. So go there, just to be sure that it's equivalent. In my project, both codes were equivalent. So you create them there, and what is happening in that, in your code, instead of using commit and success because you are still in 1.4, you are using atomic combat transaction, which means that it will work on both versions. Another example can be the fields that you have to define in your form. So form 1.8, you have, if you want to get all the fields from a form, you have to use this old syntax. Before, if you were not specifying it, it was fine. If you want your forms to be compatible, you need to do something like that. I'm not saying that's a good practice, because usually the fields on a form, you should define explicitly themselves to be sure that if you are adding, especially on the model forms, if you are adding a new field in your model, it's not going, popping by magic for a user. But that's how you make your forms really insensitive to 1.8 or not. Let's go back to the first example. In that, so imagine that I've fixed and I've created this compatibility module in my upgrade branch. I've changed all my occurrences in my project from commit and success to atomic compat transaction. Great. When I will merge it back to master, everything will be fine and everybody will use atomic compat transaction. You can be sure that at some point, somebody will just forget your work of Django upgrading and we still use the old version of the transactions. How can we prevent this kind of regression on the work you are currently doing? That's where we introduce the deprecation rules. So that's to prevent regressions. That's just a management command that will be launched every time you run, not your test, and that will say, oh, I think you are using something that will be that is not compatible with the work I'm doing on the Django upgrade branch. And we will also help people to fix these issues themselves. So how it's working, you just define a rule by a message that is quite explicit enough so that if somebody sees it, he can fix the issue. It's based on regex, so it's quite raw. We will go through a lot of parts in the code just to try to grab this, this thing that we shouldn't use anymore, and a number just to identify them. So just to give you an idea of the output of this command, if they were continuing on master to use commit and success, when we run this script, it will say that in that file, at that line, you are using this thing that has been, I would say, forbidden for the sake of the Django upgrade, and there is an ID with the description how to fix it. So that's quite interesting because it means that you can check that what you are fixing in your compatibility module, for example, is respected. But you can also use it for other things that are a bit harder to control. Like, for example, the Boolean field default parameter has changed between 1.4 and 1.6. 1.4 it was false, 1.6 it was null. So it means that if you don't pay attention to that, at some point you will have some weird behaviors because of this default one. If you want to default change, if you want to be sure that your Boolean fields are behaving on the same way, let's define explicitly the default equals false. And if you do that, your Boolean fields won't be sensitive to this just this change between 1.4 and 1.6. So there was a regret expression that was checking that there was a default value on all the Boolean fields we were defining. Another idea would have been to create a default false Boolean field that would have created in a compatibility module. But you can be sure that if you are going a bit out of the Django standards, people won't think about that. And on the same way as the transaction commit and success, they won't think about your default false Boolean field. They will still use that. That won't be compatible. So the idea there on the Boolean field, sometimes the description was not really enough to help people to fix it. So what was done was the third step, documentation, where for each ID, there was a description of what was happening and usually a sample of how to fix it. So what was really cool with that is that when the script was broken because of some deprecated rules, they didn't need me to fix it. They just had to read and just to replace it with the correct versions. So just a last thing about migrations, because migrations have changed in 1.7 and were built in. So I still wanted to get this kind of I fix everything and I merge it to master. You have a way to make your old style and new style migrations on the same branch, same project at the same time by using source from version 1. From the version 1, you can define your migration in a source_migrations repository, and then source will get the migrations there. And your new style migration, you can make them live in a migration folder. So what was happening is that at some point, I was fixing everything for 1.5, for 1.6. I arrived to 1.7, I had to create my new style migrations, but till I arrived to the end, to the 1.8 upgrade, people were still continuing to create old style migrations. So what I wanted to do is that when I was going back master, I was getting back master just to be up to date with everything. I just wanted to have a tool to tell me which migrations I hadn't yet changed from old style to new style. So the results of all this process, because it was kind of experiment, I wasn't really sure we could deal everything with compat, and the result was quite positive. I mean, we had all these really small issues in production, and especially on Django admin pages that were a bit customized and that we were not testing that much. The second thing is that there were, again, no regressions. I mean, the script that was checking these deprecated rules was catching everything that was happening. So at the end, I hadn't to do some job I already did before. So that was a part of my no stress during the whole upgrade. I mentioned Django 7, so that's an idea I had. That's a reference to Python 6 module, Django 7, to see that if I can extract this kind of deprecated rules and compatibility module to make them available to people here or elsewhere that have to upgrade the Django in a big project and that don't really know how to do that. Just to finish the key points to make it work, this approach were the quite decent test coverage. It could have been better, but that was still enough to catch a lot of issues. We were respecting a lot of Django standards. So for example, avoiding internal APIs as far as we can, or monkey patching some objects. because obviously this kind of thing are more prone to break if you are upgrading Django to the next versions. The fact that we had a lot of small changes, I mean, I've created probably 200 merge requests for my upgrades to master, but each time it was really small. So if something was breaking in 1.4, I was directly seeing it. So it was really not impacting production at all. Django ecosystem documentation and deprecation cycle obviously are helping you to understand of everything is happening. I think, as far as I remember, I never encountered an issue that was not explained and detailed in the Django documentation. And even better, sometimes Django is just saying how you should replace your old code by your new code. The screenshot is not a fake node like the first one. That's the last merge request when I had to upgrade from 1.8 to 1.9. And that was just this diff. Everything else was compatible. Yes, it was just the message of the end. So yeah, we're hiring. So obviously not to upgrade our Django project because it's already done, but yeah, that's it. So if there are some people that have things that can be really useful for that project, or if they plan to upgrade the Django and they think that can help them, I would be more than happy how to help or to put more efforts on Django 7 that is right now just a kind of alpha, maybe useful, but maybe not version. Thank you.
So, have you considered removing the wrapper layers you've added to the migrations once everybody's on the latest version?
Sorry?
Have you considered? So you were said that you added the wrapper functions in to extract the use of base Django code in to make migrations easy. Have you removed those?
No, that part was not easy. What was easy was to detect after I've migrated the first one, when there were some old migration that was still happening in the master version in 1.4, to change them to the new style one with 1.7. Now, when I was switching to 1.7, I've just recreated everything from scratch. Like obviously, I've just used that time to squash all the migrations in just one in each app I had. But if somebody has some magic, I'm pretty sure everybody has just created the new style. Or, yeah. Yeah.
You mentioned about this management command that you added that checked that you were doing any of the old stuff.
Mm-hmm.
So is that what you're thinking about putting into this Django 7 or something else? Are you planning to leave it?
Yeah. So I think these deprecation rules can be useful. I think there are. Right now, what is not happening is that what could be useful is to be able to set up the version where you start and the version where you are going to, just to sort which one are relevant to you. But I think the deprecation rules can be probably easily extendable for everybody. I'm less confident about this kind of compat module because there are a lot of things that are dependent on your project. But probably I will still try to release some part in the compatibility. I don't know if you have played a bit with the meta API of the model fields that has always also changed. And now in Django, you have a kind of equivalent between the old function and the kind of equivalent. That's something that can live in this kind of compat, so that if you have to do that in your project for any reason, because you can't be on the latest Django versions, you can at least use a code that is centralized somewhere instead of having to put it in your project. Yeah.
Are you planning to keep up with what releases in the future, or are you going to wait for the next LTS and go straight from LTS to LTS?
Okay, so at the beginning, when I've begun that, I really planned to go from LTS to LTS, because then it means that we need a quite stable product. Every time something is breaking, we can lose some money. So obviously, if you just update it every like 2 years, you can maybe break something every 2 years. But after having worked on updating like 4 versions, too much stress. I mean, when I've deployed that, with all these small changes, I was quite confident, but quite. I mean, the latest weekend when I've met that, I was not that sure that nothing would break. So right now, we will stick with the Django versions. And we also had to change from 1.8 to 1.9. I don't know if you have encountered that, but so we have a project with a lot of models, a lot of foreign keys. Our migrations in 1.8 were taking ages. When I say ages, say it could take up to 3 hours just to initialize it. Because of a known bug on when you apply the migration, there is a run-running model state. That's the first step before applying on the migration. And this step could take up to like 2 or 3 hours, which was a bug that was, I found some tickets, but it was not that clear what was producing that. And that was fixed in 1.9. So that's why we decided to switch to 1.9, because it was definitely not possible to work, especially when you were launching the test, it was taking ages to initialize. So now we are no more in the LTS, so the question is not anymore. But if I had to, I would follow the Django versions. No.
A round of applause, guys. Okay, well, I appreciate, obviously, we've run over a little bit, so I apologise for you guys. But I just want to say a big thanks to all you guys for attending this evening. The plan is to have the next one now in about 3 months' time in September. As I said at the beginning, a massive thank you to everyone at Potato, to Anna and Ola for talking, and great stuff from you girls there. Tell us a little bit more about what you're up to from Potato. Like Stephanie, I don't know if she's still here, she's probably run away. Oh, she's at the back there. Thank you so much for your help, and to Jason and everyone else here. All the other speakers, so Vlad, Gary, Tom, Roman there at the end. As I said at the beginning, it really, we can sort of help out and sort of buy some beers and pizzas and things, but without you guys giving up your time to come and sort of not only listen, but also talk as well, this wouldn't be possible. So, as I said, the next one's going to be planned for around September time. If anyone is interested in, works for a company that's interested in hosting or giving a talk, hopefully you've got a nice idea this evening of what we're all about, and it's a very sort of chilled out vibe, so it'd be great to see you there next time. But yeah, thanks to everyone again, and hopefully you'll get safe, home safe this evening. All right, thank you very much.